Okay, a very warm welcome in Java data structures session. In today's session, we are going to get started with the concepts of lists. We have already done exception handling in the previous session, and you have access to the resources. We have two parts for exception handling, which we completed. One is the exception handling, and second one is the advanced exception handling. Now, in lesson 3 today, we'll get into the lists data structures in Java programming language. Now, coming to the list data structure, we are going to have a quick introduction to what a list is. The list is a compact data structure which we use from java.util package. Okay. List is an interface in Java programming language, and we are going to understand how we can make use of collections, iterable, and this interface in order to create ordered collection. Okay. Now, there will be two resources which we will be using. One, the documentation from Java itself, and second, visualgo.net, which will give us simulation of list data structures. So the resources which we will be using, first one will be the documentation for the list, and second, we will be using this website, which is quite effective, known as visualgo.net. This website visualgo.net gives you a lot of simulation of the data structures which we have to implement so as to have a better understanding of what we are implementing. Currently, we will be using linked list concept in visualgo.net to visualize what is happening, and then we are going to code it as well. So here you can see that there's a lot of definitions available for the list data structure, for linked list, for stack, queues, and other data structures which are important, inclusive of, let's say, the doubly linked list, summaries, and other potential data structures. Okay, so we will be using these resources in the session. So second one also, I would like to share that with you, and I'm going to put it here. Now, coming to what is a list. So list, what it is an ordered collection. And this is also known as a sequence. The user of this interface has precise control over where in the list each element is inserted, which means you have an ordered collection and you have a control that you can insert an element at a specific location in the list. The user can access elements by their integer index, which means from the list, you can quickly access an element by giving its index position. And depending on the index position, you can quickly get the element out. And similarly, you can search for elements in the list. Okay. This is the definition of how we use ordered collection or sequence, which is list in Java programming language. Similarly, there are a couple of comparison. It says, unlike set, lists typically allow duplicate elements, which means in case if you have duplicate elements, you'll be able to insert duplicate elements into the list. More formally, lists typically allow pairs of elements E1 and E2 such that E1 dot equals E2, which means the duplicate elements can be added. And they typically allow multiple null elements if they allow null elements at all. So in case if you want to insert null elements into list also, that is also possible. Now, it is not inconceivable that someone might wish to implement a list that prohibits duplicates by throwing runtime exceptions when the user attempts to insert them, but we expect this usage to be rare. So what you can do is you can implement a list in such a way where you don't want duplicates. And in that case, what you can do is you can throw runtime exceptions in order to show that the list already has the elements. And I think you already understand how to throw the runtime exceptions. Okay, we have already done it in the previous session. Now, the list interface places additional stipulations beyond those specified in the collection interface on the contracts of iterator, add, remove, equals, and hash code methods. So what do we have is there are additional options available, the methods available with iterator, add, remove, equals, and hash code in the list, which we might be using. Okay. Then what do you have? The list interface provides 4 methods for positional access to list elements. Okay. So what are those? We are going to understand. So lists are 0 based. Note that these operations may execute in time proportional to the index value for some implementation. So for example, there's a linked list class, which we might be using to implement the list. Thus, what you can do is iterating over the elements in a list is typically preferable to indexing through it if the caller does not know the implementation. So what you can do is, in case if you don't know what element has been inserted into a list, you can iterate over the list of all the elements and you can access those elements or process those elements according to your program needs. Followed by the list interface provides a special iterator, and that iterator is known as a list iterator. What list iterator does, it allows element insertion and replacement and bidirectional access in addition to the normal operations that iterator interface provides. So we are going to see how we can insert element through iterators, how we can replace those elements if required through an iterator. And you can have a bidirectional access, which means you can access from left to right and from right to left the lists, which means in the positive directions, as well as we can iterate the list in the negative directions also. Okay. Similarly, the list interface provides a lot of methods which we might be using in, and you can see that there is a complete list of methods available. So what we can do is we can append the specified element to the end of the list. We can insert the specified element at a specific position in the list. And there is a lot which we can do. Okay. Like we can perform an add all function. We can perform a clear function. We can perform a contains function. So we are going to do all of those. Okay. Now, first, we are going to get into the linked list implementation to give you an example. So what could be a list? So if I create a list and I'm going to create a user defined list, let's say 1, 2, 3, 4, 5. So I've inserted 5 elements. So we have access resource number 2, visualgo.net, the list. So here we are going to create a sample list. Let's say I'm going to create a list for, let's say, 10 elements. So I'm going to insert an ordered list. Let's say I'm going to insert some 6, 7 elements into the list. And when I click on go, you can see that here is an example list. What the list does, I'll quickly show you. So here is a complete list of your elements, whatever elements you have inserted within a list. So you have a head of the list, you have a tail of the list. Okay. How we specify the index values here, that also I would like to tell you. So when it comes to the position, okay, now every element is at an index. So as you already know, the indexes starts from 0. Okay. So the first one will be at index 0, then the next one will be at index 1, index 2, index 3, index 4, index 5, and index 6. Okay. These are the positions with which we can access the elements from the list. Similarly, if I show you, there is the negative indexes are also available. Okay. And with the negative indexes, what do we mean? We mean that it could be -7, -6, -6, -5, -4, -3, -2, and -1. So this means that we have a bidirectional way of accessing the elements from the list. Is that clear? So
Yes.
what we can do is we can give name of the list, and then we can provide the index value which represents position of an element in the list. Okay, and that's how we can access it. So this is something which we are going to implement. Now, what we can do is we can insert a list at a specific index. Okay, suppose I want to insert a list at index number 2, let's say. Okay, so what I will do, I will go to both indexes, which means I want to insert an element at index number 2, and the value is going to be, let's say, 8. Okay, so once I click on go, you can see that I'm going to find out index number 2, and on index number 2 I have added a new element, that is 8. Can you see that?
Yes. Yes.
Similarly, what we can do is we have certain ways that we can remove an element at a specific index. So what am I going to do? Let's say I want to remove the element available at index number 2. So if I go and click, if I click go, so I'll find out the index number 2, and I'm going to delete it, and the list is going to be adjusted automatically. I think this is clear.
Okay. Yes.
Similarly, we can search within all the elements of the list. So what we can do is, in case, let's say if I want to find out number 6 in the list. So what I can do is I will go to the head, I will iterate over the list of element, and I'm going to match it. If my search term equals to equal to the element available at a position in the list. I believe this is clear.
Yes.
So now you can see that we have been searching 6, and we got to find out the element in the list. Sometimes it might happen that we are trying to search an element which might not be available in a list. Suppose I'm trying to search 9. So once I click on go, it will iterate over the complete items of the list, and it can tell us that the list not found, the list element not found.
Yes.
This is how the list operations are done. Now, what am I going to do? We are going to implement the concepts. Okay. So in order to implement it, what do we need? We are going to make use of these methods, which means these are the following method summaries available with which we can actually do a lot of operations with the list data collections. Okay. And we will be implementing the list interface. The list interface can be implemented in this format. You can define list, and you can define E. E stands for the type of element in the list. So what do we have is the list are homogeneous elements. Homogeneous means in Java, the lists are homogeneous, which means you have to define the type of data the list can handle. Okay. So if you want only the list should be able to handle strings, then you have to define string as an E. E stands for the element, the type of the element in the list. Okay. Now, so there are various other classes. There are abstract list available. There are abstract sequential list available. There is an array list available. There's an attribute list available. There is a copy on write array list available. There's a linked list available. There is a role list available. There is a role unresolved list available. And there are stacks and vectors are also available in Java programming language under the package java.util. Is that clear? So yes. What is a list? List is a class which extends collection. Okay. Collection is a super class which the list imports, okay, inherits, and then we get access to a lot of methods. So what are the methods? These are the methods which we are going to implement. So initially we are going to start with the list class, okay, and then we will see how we can use the others also. So what am I going to do? I'll start Eclipse. Okay. So we were done with the project exception handling already. So I'm going to close this project. And now I'm going to get started with a new project. And this project is going to be known as the lists. Okay. So within this project, I'm going to create a new class. And this class is going to be a public class with the name myLists. Okay. And I'm going to generate the specific stubs in order to implement the desired concepts. So I'll keep it on a side just to show you how we are going to implement the lists and how we are going to run them. Okay. Now, so how do we have to use it? So we have to implement this interface list E. Okay. List is an interface which you can use. And let us just have a quick look. So what am I going to do? Let's say I'm going to define a new list. Okay. And I have to define the type. So I will say, I want to use, let's say, string. Okay. So I've defined a new list. Now this list has to be imported from the package java.util. Okay. You can import list from java.util. I cannot find the list by default here. I'm getting one from the java.awt package. But what I can also do is I can try in this way. Import java.util.
Okay.
Okay. So util.list. Okay. And since it's an interface, so what we can do is we can use it in a way where we can implement the list. We can implement the list of type string, something like that. And then what we can do is we can add the unimplemented methods. So now once we add the unimplemented methods, you can see that we get access to all the methods which we can override. Okay. So this is the way of implementation of an interface. Okay. Since you can see that list is an interface. Okay. It is not a class which we can use directly. It is an interface whose methods we have to inherit, and then my list is going to become a custom list. Okay. Is that clear?
Yes.
So then what we can do is, we can quickly check all of these functionalities. We can modify all of these, how do we want the codes to be processed? Okay. What do we want when we have to implement contains all, add all, and things like that. So instead of getting into the list interface initially, first I want to create some more classes, some more test cases where I want to explain you how the list works properly. So first I'm getting into some of the common concepts like abstract list, which is a class which you can implement. Okay. Then what you have is you have an array list, which you can implement. Then you have a linked list, which you can inherit. All these are classes. Okay. So we are going to use the classes from those collections that you can do first initially, and then we can make our own custom lists using the interfaces. Okay. So with which we are going to start, I'll quickly take you to the first one. And let's say I'm going to start with the array list. Okay, let's just make an array list initially. Then we can get into the linked list and the others also. So what is an array list? Array list is a class which we are going to implement. And I'm going to make a new class. And let's say I'm going to call it as my array list exam test. Okay. So within my ArrayList test, what are we going to do? We're going to import the package java.util so that we can get access to the class ArrayList and we can create a new instance. Now, what do you need to understand is this ArrayList is an resizable array implementation of the list interface. Okay. So this implements the list interface, and there are certain methods which have been modified in it, which helps you make it a resizable array implementation. Okay. What it also does, it implements all the optional list operations and permits all elements including null. In addition to implementing the list interface, this class provides methods to manipulate the size of the array that is used internally to store the list also. There are various methods like size, is empty, get, set, iterator, and list iterator operations which run in constant time, which means these functions of array list executes in big O of one time complexity, which makes it a perfect utility when you have to write a performance oriented program. Okay. So in case if you have certain operations like where you have to implement to get the size of the list, or to check if the list is empty, or to get an element from the list, or set an element into the list, or iterate an element into the list. So all these operations will be executed in a constant time. So which makes it a perfect utility to use in your Java programs. Okay. Now, the add operation runs in constant time, that is adding n elements requires big O of n time. We call it as amortized constant time. Okay. So big O of n is also a complexity which comes under the good or the fair time complexities. Okay. So this means as soon as the number of elements are increasing, your time will increase. All of the other operations run in linear time. Okay. So the constant factor is low compared to that for the linked list implementations. Okay. So we can also check the linked list implementations, which is also a good way of using lists in Java programming language. Okay. Now, each array list instance has a capacity. The capacity is the size of the array used to store the elements in the list. It is always at least as large as the list size. So as elements are added to an array list, its capacity grows automatically. The details of the growth policy are not specified beyond the fact that adding an element has constant amortized time cost. Okay, which means the number of more elements you will have in your array list, more time cost will be required to process it. Okay. Now, an application can increase the capacity of an array list instance before adding a large number of elements, using the ensure capacity operation. So this may reduce the amount of incremental relocation. So this is to write the performance oriented codes. Okay. Now, so there are various ways of implementing the collections. So what do we have is there is one method which is known as collections.synchronized list method. So what it does, it helps to create an array list and prevent the accidental unsynchronization access to the list. So this is also a nice way of implementing the list where you can use collections.synchronized list and implement the list. Okay. So what do we mean? This means that this implementation is not synchronized by default. When you implement an array list, it is not synchronized. So what is the meaning? If multiple threads access an array list instance concurrently, and at least one of the threads modifies the list structurally, it must be synchronized externally. Okay. So let's say there are multiple threads who are accessing the same list. Okay. And suppose one thread is modifying the position of the elements in the list. Okay. So what do you need to do is by default, it is not synchronized. So it might show errors in the operations. So what do you need to do whenever you are creating list? It is always a good idea whenever you are writing a multi-threaded application or a distributed application, you need to write the list with the synchronized list method. Okay. So this is typically accomplished by synchronizing on some object that naturally encapsulates the list. So if no such objects exist, the list should be wrapped using the collections.synchronized list method. Okay. So these are some of the great information which we can only get from the original implementations of original documentation. Okay, got it? Now, so we are going to implement the array list. So what it does, first we have to call the constructor array list, which constructs an empty list with an initial capacity of 10. Okay. So we are going to implement that. Let's say we are going to implement public static void main. And I'm going to use string arguments. Now, what are we going to do? First, we have to construct an empty list with an initial capacity of 10. So what we can do is we can quickly create it using new array list. Okay. So we got the new array list. And now what we have to do is we can import the new array list from java.util package. Can you see that? We got the array list initialized. Okay. So I can call it as my array list, and I can create the object, create a local variable, my array list. Okay. So I've got my array list created. There are other ways. By default, it creates an empty array list with the capacity of 10. But what you can also do is you can also construct a list containing the elements of the specified collection in the order they are returned by the collections iterator, which means, let's say if you already have a collection, you can make an array list out of that collection, which means you can convert a linked list into an array list or an abstract list into an array list. That is also possible. Okay. Similarly, in case if you want to construct an empty list with the specified initial capacity, then you can use this method by defining the number of elements it can hold by default. But it extends. As soon as you add an element, it extends the storage space. Okay. Now, what are we going to do? So once we got an array list, so what am I going to do? First, I'm going to append the specified element to the end of the list. Okay. So what am I going to do? I'm going to call my array list. Okay. And I'm going to call a method add. So what we can add, you can append the specified element to the end of the list. Okay. Which means you can define the type of the element which you want to store. It could be a string, it could be an integer, it could be double, it could be float, depending on your choice. Also, you have another add method in which what you can do, you can insert the specified element at the specified position in the list. Okay. Which shifts the element currently at that position and any subsequent elements to the right side of the indices, the way which I have already shown you in the visualgo.net simulation. Okay. What are the parameters it takes? It takes an index at which the specified element needs to be inserted, and then it needs an element, the element which we want to insert into the list. So since I have an empty list currently, so what am I going to do? I'm going to call an add method. Okay. And in the add method, what am I going to do? I'm going to add an argument, and let's say I am going to insert the numbers. So first I've added 1 in it. Okay. Similarly, I'm going to add up a few more elements. Let's say I've got my array list dot add. I'm going to add 2. Okay. Similarly, I'm going to add up a few more elements. Let's say 3, 4, and 5. Okay. 3, 4, and 5. Okay. I've got all of these elements. Now, what we can do? You can also add an element at a specific index. Okay. Then what you can do is you can clear, you can contains, you can ensure the capacity, you can write a for each. Okay. You can check if it is empty, you can get the last index, you can get the iterator, you can remove an element, you can set the size. So there's a lot of things which we can actually do. Okay. So what am I going to do? I would like to show the element at a specific position. Okay. So first, use system.out.println. And I'm going to show my array list. And I want to show that I want to get the element at index position 1. Okay. Okay. So, So what do we have to do? We have to call the get method here. Get is the method, and we have to get the index position. So if I am getting the index position 1, so it is going to give me 2. The value will be 2 because this is position 0. This is index position 1. This is index position 2. This is index position 3. And finally, the index position 4. Okay. So once I do that, and if I run my code, I'm going to click on OK. Now you can see that it gives me 2. Okay.
Yes.
At the index position 1 would be 2. Similarly, I'm going to grab it eventually in a specific, in a different manner. So I'm getting some elements at index number 1, 0, and 4. So once I run it, once I click on OK, you can see that I got those elements 2, 1, and 5. So I know how to add an element. Now what am I going to do? I'm going to add an element at a specific index. My array list, okay, dot add an element at a specific index. So what am I going to do? I will say that I want to replace the order. So I want to add an element at index position 1, and the element which I want to add would be 6. Okay, like this.
Okay.
And again, I'm going to print out the elements. Okay. So once I run it, so initially we are going to get the element as 2 at that position.
Yes.
But finally, I'm going to get 6 because
6.
I have added it. I have replaced the element. Okay. Then what you can do is you can have 2 collections and you can quickly pass that collections and add all the elements of that collection into this list. Okay. Which means I'm going to create new array list. Okay. So I'm going to create a new array list, and this is going to be my list 2, let's say. Okay. New array list. So what am I going to do? I am going to add list2 dot add all. Add all is a method wherein I can quickly pass another list, which is my array list. Okay. And then you will be able to observe that if I print the list2, I'm going to get the same elements. Okay. So what am I going to do? I'm going to change list2 here, list2 and the list2. Okay. And I'm going to say system dot.
So it will get the 6 also instead of the 2.
Yeah, just a second. So printing list2. Okay. And we're going to do printing list1 and updating the list. Updating element. Okay. So I'm going to save it and I'm going to run now. So now you can see that I printed the list 1, which was 215 initially.
Yes.
Which I replaced it at 2, replaced it 6, and then I got 614 because I have got the elements updated over the list. Okay, for 1, 0,
Yes.
and 4. Okay, since I have inserted an element, the numbers shifted to the right. Okay, that is why I'm getting 4 here. Clear?
Okay. Yes.
So in the same way, you can add at a specific index also, which means you can add to a current list and you can specify the index position from where the elements needs to be copied. Okay. Now, what am I going to do? Let's say if I'm going to clear my list. So I will access list2 dot clear. Okay. We can clear the list. So again, if I'm going to print the list2, I'm going to get nothing out of it because it's already clear. So I'm going to run and it is going to throw me an exception, index out of bounds exception, because I'm trying to access those indexes which are not available in the list because the list is already cleared. Got it?
Okay. Okay. Yes.
So we can handle index out of bound exception with a try catch block. Okay. So what we can do is we can quickly put into this try catch array we can call it as index out of bounds exception E. And we can print a statement system.out.println list is clear. It's clear. Okay, got it. So once I run this, so my program is not going to be terminated. We got to see that I cannot clear the list because it is already cleared. Okay. Now, what you can also do is you can clone. With clone means you can return a shallow copy of the ArrayList instance. Okay. Which means, let's say, I can clone the list. So what are you going to get? You're going to get an object. A shallow copy of the ArrayList means, I'll show you. So we are going to clone the list, my ArrayList. Okay. My ArrayList dot clone. Okay. I'm going to clone it. So what it is going to give it to me, my array list clone. Okay, something like this I'm going to get. So I'm going to create a local variable and I can actually create it of the array list type. Okay, and it will ask me that you have to cast it to array list. So I'm going to typecast it to array list. Then what I can do is I can print the elements out. Okay, what I can do, I can print the elements out for my array list.
Okay.
Clone, sorry. Okay, I'll put it like this and I'll printing from clone, printing from my array list clone. So I'm going to change it to clone, my array list dot clone, my array list dot clone. Okay, let's run it. So once we run, you're going to get 614.
Okay.
Printing from the my array list clone. The list 2 has been cleared and we are printing
Yes.
from my array list clone. Okay. Now, what I can do is, even after the clone, I've done the clone, but what I want is, I want to, I'll do something like this, system.out.println, clear the my array list after cloning, just to show you what happens. Okay. So what I'll do, I'll use my array list dot clear. So after cloning, I'm clearing just to check what's happening. Okay. So I ran it. I've clicked on OK. So now you can see that still I have got access to the clone. Okay.
Okay.
It's going to make a complete copy of the array list. It's not like object reference, but it is going to make a complete copy of the element in the memory.
Okay.
Okay. Now,
so there are two ways to copy. So we can add the elements of list 1 to list 2 and
add all into one, or else you can make a complete copy of the existing list.
Okay.
Okay, got it?
Yes.
Now, what do we have is we have an object, we have a method known as contains. And what it does, you have to define the element which you are trying to search in the list, and it is going to give you a Boolean response, which means true if the element exists, false if the element does not exist. Okay. So what we will do in my array list clone dot contains, I'm going to check whether it contains 6. Okay. So I'm going to say system.out.println check if my array list clone contains 6. Okay, that's what I'm checking.
Yes.
And I'm going to get the result. And this is going to be Boolean. Sorry. I'm going to create a local variable Boolean. Okay. If I'm going to say result. If it is true, else I'm going to print a false statement. Okay. So I'll say system.out.println 6 exists, and, or let's say I'll say item exists or item doesn't exist.
Okay.
Item doesn't exist. So I'm going to run it. So once I run, so it says under my ArrayList clone, I have, but we had 6, right?
Yes.
Oh, sorry. My ArrayList
So
clone, we need to check in. My ArrayList has been cleared, right? That is why it's saying
yes, yes.
it's not there. Okay. Now let's run it again. So you can see that the item exists.
Okay.
Okay. Got it? So
Yes.
that's how we can quickly implement the methods which are available. Now, what is your task? You are going to implement the other methods available here, okay, in the bottom. इन सारे methods को आज आप implement करोगे. So what you need to do, you need to understand the return type, the name of the function, and the definition of the function. That how is it implemented? Okay. Then you are going to implement all of those and update the code in your repo, and then share the code with me on the board.